So, to start off section 4.1, today's section should be pretty short, pretty straightforward. It's just an introduction to sample surveys, so just some background before we get to the different sampling types that we want to use in order to collect our data. So, the first thing, we need to have a discussion and define a couple key terms. When we collect data, we are trying to answer a question about a population by using a sample. So we need to understand what we mean when we say population, what we mean when we say sample. So if I'm saying the population, what am I talking about? What do you think? Use what you know, previous knowledge. It's a pretty straightforward idea here. I'm trying to answer a question about a population. So how would I define the population? All right, the entire group of people that I'm actually interested in, right? So when I talk about population, we're talking about the entire group of people that we want information on. So one of the first things that's always going to happen whenever you're trying to answer a question using something with data collection, you need to be able to identify your population of interest. You need to understand who or what you're trying to study. So I have this question I want answered. Well, who or what is this question about? Who am I actually interested in overall? So that's what we mean when we say the population. It's the entire group of people we want to get information for. Okay? Now, populations can be very large, can be very small. Okay? So a population, we could be interested in how all U.S. adults respond to a given question, or how they feel about a certain topic. That's a pretty large population. We could be interested just in something to do with the AP Stat students in Papillion La Vista High School. That's a very small population. There's only 38 of you. Okay? So populations can be large or small based on what we want to know and who we want to know about. Okay? Now, populations, if we wanted to answer a question about a population, the common sense idea would be to say, well, let's just ask everybody. Okay? So if I had a topic that I wanted to research and I was specifically interested in you guys, AP Stat students at Papillion La Vista Monarchs, could I ask every single one of you the question and get my information from it? Yeah, I'd have access to all of you. I'd be able to ask each and every one of you, right? But if we look at the other example I had, which was we're interested in how all U.S. adults respond to a certain topic, would it be plausible or even feasible for me to go out and ask every single adult in the U.S. that question? No, it's not. So one of the things we have to work with then, our population may not be something we have access to the entire group. So that's why we have to use this idea of sampling to figure out what we want to know. So a sample is a subset of the population. So it's a group within that entire group of individuals I'm interested in. Now, one of the things here, and this is what we're going to spend a lot of next week talking about, is this idea of representative samples. So there are ways to sample that give us the best chances of getting representative samples, and then there are some that give us really bad samples, which means we don't get useful information from it. When we say representative, what do you suppose we mean? Okay, it could be diverse, wouldn't necessarily have to be.
An accurate, selection of the population.
Yeah, so basically, if I were to look at my sample, it should be a miniaturized version of my population. Okay? So if I have both men and women in my population, I should have both men and women in my sample. right? If I don't, then I'm going to run into issues of maybe differing opinions based on gender or something like that. So my sample should basically be like a little miniaturized snapshot of my population. Okay? And so we're going to talk next week about how to gather samples so that we have the best chance of getting something that's representative. So it's a group of people that we can actually get to, that we can actually ask whatever topic we have. Does that make sense? Okay? So, one of the things that's going to be important for you guys, not only in your own research, because at some point I think we're going to be doing a project where you guys are going to come up with a question that needs to be answered. You're going to figure out who your population, who your sample is going to be, collect the data, analyze the data, report. Okay? So that's an important aspect of it, is being able to identify for yourself. But there's other times where you might need to look at other people's research. You might need to look at what other people are reporting and decide, did they give us an accurate description? Did they do things correctly? Can I trust the information they're giving me? And part of that comes from being able to identify population and sample. So did they identify their population correctly? Did they have the correct sample? Or you guys need to be able to identify, in this given scenario, what was the population of interest, what was the sample? So we have two examples up here on the board. So the first one, a furniture maker buys hardwood in large batches. The supplier is supposed to dry the wood before shipping, because wood that isn't dry won't hold its size and shape. The furniture maker chooses 5 pieces of wood from each batch and tests their moisture content. If any piece exceeds 12% moisture content, the entire batch is sent back. So if we're looking at that situation right there, we want to identify the population of interest and then the sample that they looked at. So if we're sitting here and we're looking at this first scenario, what would be the population of interest? So what's the furniture maker interested in? What's the population? The hardwood, right? He's interested in the entire batch of hardwood. So every time the supplier brings a batch, they have to test that batch, right? Now these batches might be so large that it's not feasible to test every single piece, right? So the entire population that they're interested in is the entire batch. What is their sample? What do they actually study? The 5 pieces. So each time they bring a large batch, they just randomly select 5 pieces and test the moisture content. Okay? So population, entire batch, sample, the 5 pieces they actually select to test. Does that make sense? Okay? Second scenario. Each week, the Gallup poll questions a sample of about 1,500 adult U.S. residents to determine national opinion on a wide variety of issues. So Gallup poll questions a sample of about 1,500 adult U.S. residents to determine national opinion on a wide variety of issues. So, in this context, what's our population of interest? Who is Gallup interested in? All U.S. adult residents, right? So they want to answer a question about every adult U.S. resident. What sample do they take? Yeah, the 1,500 that they actually contact per week. So every week, if they're contacting 1,500 new people, each time they're creating a new sample. So 1,500 adult U.S. residents would be the sample part. Does that make sense? Okay, so population and sample, very important that you can discern the difference between the two, be able to identify, given a scenario, or, given your own research question, being able to identify for yourself, what's my population of interest, what's the sample I'm going to collect. Now, sample surveys are one method of data collection. We're going to talk about 3 different types in this chapter: sample surveys, observational studies, and experiments. Okay, so observational studies and experiments we'll get to in the next section. For right now, we're going to focus on sample surveys. So you have a question, You need to get it out to the people you get information from. Okay? So a sample survey is just a study questioning a sample of a population. So, anybody in journalism? Okay. So in journalism, or if you got the school magazine today, The Scepter, they go out and sometimes they'll poll students from the school and ask them their opinion on certain topics, right? That's a sample survey. They had a question, they went out and took a sample of students, asked the question, got the information, reported. Okay, so that's what a sample survey is. It's just a question or a set of questions that you want your population or your sample to answer. Now, there's a key distinction here that we need to make sure we make. There's this idea of a sampling frame. So our population is everyone or everything we happen to be interested in. So the entire group we want information on. The sample are the people we actually get information from. So who actually answered our question, or what objects did we actually measure whatever we were trying to measure. But there's this other idea of a sampling frame. The sampling frame are the individuals that the researcher has access to. These are the people that they could draw their sample from. Okay? Now, sampling frame is similar to population, and in some cases it might be the exact same thing, because you might have access to your entire population of interest. But other times, your population of interest, you might not have access to every single person or every single object within that population. So the people you do have access to would be referred to as your sampling frame. Okay? For instance, when Gallup does a lot of their polls, a lot of times they generate their samples by randomly selecting phone numbers. Okay? Now, if we think about that, their population of interest is almost always, or in general, all adult U.S. residents, or all U.S. residents, right? But if they're only sampling from randomly generated phone numbers, who are their sampling frame? People with landline phones, which in this day and age is starting to decrease little by little. People are stopping or not having landline phones as much anymore because they're relying more and more on their cell phones, right? So when they take their sample, they don't have access to their entire population because the entire population doesn't have landline phones. So their sampling frame would be the U.S. residents who actually have phones that they can be contacted on. Does that make sense? If you were going to be doing a study about something within the school here, and you go to the office and you get a list of all the students at Monarchs, in that case, your entire population of interest was the entire student body. And if you get a list from the office that has the entire student body listed on it, then you have access to the entire student body. So in that scenario, your population and sampling frame would be identical. You actually would have access to all of your population. Does that make sense? Okay? So the breakdown, the way to kind of keep this straight, your population of interest, that's everyone you want to know about. So everyone or everything you want information on. Your sampling frame are the people or objects you actually have access to. And then your sample is the people or objects you actually gather information from. So each step tears it down a little bit farther. Who do I want to know about? Who do I have access to? who do I actually get information from? Is everyone okay with that idea? Okay, so once we can discern the difference between population and sample, the next thing we have to decide is the measurements we collect. Because depending on where we get our data values, that will determine what we can and cannot do with that information. So, when we run our sample surveys, if we collect a sample and we calculate some value based on that sample, we are calculating a statistic. So this is extremely important. A statistic is a value calculated from a sample. Now, what sometimes happens, people, when you're reading through scenarios and trying to decide population sample, statistic, and parameters, what we're going to talk about next, people tend to just pick every number out of a problem and make it something. So this number is a statistic, this number is a parameter, this number is a statistic, okay? You got to be careful with that. Statistics are actual calculated values from the sample. It is not the sample size. So one of the things they may report in their analysis is how many people they actually sampled. That doesn't have anything to do with this idea of a statistic. It needs to be a calculated value that came from your sample. So the big thing to remember here, if it is a value that comes from a sample, it is a statistic. It's an estimate of the true population value. So that might be something else you write down with statistic. It's an estimate of the true population value. Okay. So we have a question we want to answer about an entire population. We go out and take a sample, we calculate a given value. So we calculate a statistic, we get an estimate. Now, if we had access to our entire population, and we were able to get information from our entire population, we would be collecting or calculating what's called a parameter. So this is the second really important part here. These are the two pieces of data that you can be working with. So a parameter is a value calculated from the entire population. So if I have access to my entire population, I get information from my entire population, and I calculate whatever value I was interested in, I am getting a parameter. I'm getting the exact value for my population of interest. Now, as we discussed before, the whole idea of sampling, the whole reason it comes about, is the idea that not every population is reachable. We can't always ask every single person in our population. It wouldn't be either feasible, cost-effective, whatever the reason. So, there are most often times when we don't know the true value of the parameter. We don't know the exact value for our population. Which is why we take samples, and from that sample we create a statistic and use that statistic to estimate the parameter. Okay? And again, parameters are not the size of the population, it's a value calculated from the information gathered. So the big thing here, if it's a value that comes from a population, it is a parameter. They should be pretty simple to keep straight. Sample, statistic, S and S. Population, parameter, P and P. Okay, so one of the things you're going to be expected to know is, given a scenario, is the value that they calculated an exact value for the population? Is it a parameter, or Did it come from a sample, which means it's an estimate, and so it's a statistic. So it's important you know the difference here. Okay. So, another thing to note here, we're going to be starting to use notation for different calculations, maybe mean, maybe standard deviation, later on proportions, things like that. Whether a value is a statistic or a parameter will determine what notation that particular value gets. So if we have statistics, we use essentially the Latin form of the variable. So for mean, we use x bar. For standard deviation, we use plain S, just like what we've been using in the first 3 chapters. However, if we know the population parameter, so if we actually know the exact value for a population, we use Greek letters to denote those values. So mean becomes mu, standard deviation becomes sigma. So that can sometimes be a giveaway too. If they give you a situation and they report that mu equals 26, for instance, the fact that they used mu means it's a population value. It's a parameter. If they report the standard deviation and say S equals 2.76, S tells us it's a sample, which means it's a statistic. So the notation itself can tell you what type of value it actually is, statistic versus parameter. Okay with that? Okay. So let's do a couple examples here. A study of 456 high school students by the National Center for Chronic Disease Prevention and Health Promotion reports that 21.7% of U.S. teens never or rarely wear seatbelts. Okay? So, if we look at this, what's our population of interest? Okay? So, U.S. teens, right? So, U.S. teens. What's our sample? The 456 high school students. Okay. Now, what is the parameter of interest? Now, what this is asking, it's asking what were they trying to measure overall? So this is another term we need to discuss. When they say what's the parameter of interest, they don't want a value. They want to know what were we trying to measure. How many in what fashion though? Did they want the number of students that? What percent of U.S. teens wear seatbelts, right? So the parameter of interest is the exact percent of U.S. teens who wear seatbelts. Okay? So when it asks for a parameter of interest, it's asking, what are you trying to measure? Don't give a value for that. Don't say it's whatever percent, or don't say it's whatever number it happens to come out to be. It's asking, what are you trying to measure? So right now, we want to know the exact percent of all U.S. teens who wear seatbelts. Okay? Now, if we look at what they did here, 21.7%, there's my calculated value. So this is the value I'm interested in identifying as a statistic or a parameter. So when they calculated this 21.7%, did that come from the population of all U.S. teens, or did it come from a sample of U.S. teens? it came from a sample. Okay, that's what they specifically said. From 456 high school students. There are definitely more than 456 high school students in the U.S. who are capable of driving, right? So we're looking at a sample, which means 21.7% would be a statistic. So this is an estimate of the true percentage of students who wear seatbelts. Does that make sense? Okay. Here's the next one. Of all students at PLHS, 45 are students who have been absent for more than 2 weeks of the semester. So in this case, what's my population of interest? PLHS students. Okay, so I'm interested in all PLHS students, right? What am I trying to measure? How many students have been absent for more than 2 weeks, right? So that's my parameter of interest. So if I look at the problem here, of all students at PLHS, 45 are students who have been absent for more than 2 weeks. So 45 is my calculated value. Did that come from the population, or did it come from a sample? What do we think? From the population. How do we know it came from the population? All right. The first phrase here, of all students at PLHS. So they're telling you they looked at every single student. So they looked at every single person in our population of interest, which means this 45 is the exact number of students who have been gone for at least 2 weeks of the semester. Okay, so this would be a parameter because it came from the overall population. Okay with that? Okay, here's another scenario. A study is done to determine how many hours per week students spend on the internet. 25 students from each grade at PLHS are asked their internet habits. The results show that on average, students spend about an hour and a half each night of the week online. Okay, so here's what I want you to do. You and a partner come up with the answer for these 5 pieces. What's our population of interest? What was the sampling frame? What sample did we take? Do we have the parameter value? And then what's the statistic value? So remember, if it's a parameter or statistic, you may not know one or the other, but you should be able to figure out the other one. So using that scenario there, I want you to answer those 5 pieces. You want to get together and work with someone, talk it out? answers? All right. So let's start with Michael, Sam, and KJ. What do you guys think for the population of interest?
All PLHS students.
All PLHS students? Does everybody agree with that?
All students in general.
That's the question.
All students in general.
What do you guys think?
All students. Yes.
Okay. All students in general. Now, they started off with all students in PLHS. Why did they change to all students in general? Okay. So it's just asking. The question is, how many hours per week do students spend on the internet, right? Now, if they had said, how many hours per week do students at PLHS spend on the internet, then we could say it's definitely or confined to PLHS. But since it's not specific, we have to assume they're asking for all students. Okay? So all students in general would be our population of interest. What is our sampling frame, Kristen and Larissa?
For a student at PLHS and the different grade levels.
Okay? So it'd be all of our students at PLHS, right? So they took 25 students from each grade at PLHS, which means they had access to all students at PLHS. So our population was all students. The people we had access to, our sampling frame, were students at PLHS. Everyone okay with that? Okay. So what's our sample, Hope and Kylie? Yeah, the 25 students from each grade. So the 25 students they actually asked information on, or gathered information from each grade, would be considered our sample. And it's important, guys, when you're here, you're as specific as possible. If you just simply said 25 students, that's not correct. It's 25 students from each grade, right? So you need to make sure you have everything included in your description of your different parts. Everyone okay with that? Okay. Now, before we get to parameter and statistic, what is the parameter of interest? What are we concerned with calculating and finding? How many hours they spend on the internet, right? So that's what we want to know. So this next part, though, is saying what is the parameter, so what's the actual value, and statistic, what's the estimated value. So if we're looking at this scenario, Danny and Autumn, what is our parameter? What's the actual value? We don't know. We didn't get information from the entire population, right? So in this case, this is one of our many examples where the parameter is unknown. We don't know what specific number of hours students spend online. So our parameter we don't know. But our statistic, so that's the value we calculated from our sample, would be what? One and a half hours. Now, be careful with this. 1.5 times.
14. Or is it just 1 week?
Just the 1 week, right? So notice, we want how many hours per week students spend online. How did they report the value? 1.5 hours each night, right? Now, if you said 1.5 hours each night, okay, that would still count because you're encompassing the entire week in that case. But if we wanted to put it in the units they asked for initially, we'd take 1.5 times 7. So our statistic would be 10.5 hours per week. So they're saying the estimate for all students is that they spend about 10.5 hours per week online. What do you guys think? Does that sound pretty average or pretty normal? For you guys, you're about on 10.5 hours a week. Okay. So those are some made-up numbers, but that's basically what we're going to be looking at. Okay. So that's all we want for today. Can you identify a population sample? Can you identify sampling frame? What's the parameter of interest? Can you tell the difference between parameter and statistic? All of those things are going to be very important when we dive deeper into the different sampling methods and how to collect. So your assignment is going to be this worksheet here, working on just the stuff we just got done discussing.